Good morning. This is Professor Shannon Gracie. We are back on the last section on 3.5 from the Blitzer Introductory and Intermediate Algebra for College Students textbook. And today we'll be covering how to use the point slope form of the line to write equations of a line. This is very important, especially when I see you guys in calculus. We're going to find slopes and equations of parallel and perpendicular lines, and we'll write linear equations that model data and make predictions. So here we go. Why don't you pause the movie and get warmed up. The first one is a practice for order of operations, and the second one is a practice of graphing a line using the y equals mx plus b form. All right, on your mark, get set, go! Okay, let's see how you did on the order of operations problem. So here we go. I'm going to leave this 5 hanging out while I complete what's inside these parentheses. So here we go. Remember, the square brackets are just another grouping symbol. And what we need to do is distribute that minus sign throughout the parentheses within the brackets. So we'll have 2 minus 7x minus 2. Alrighty, so this matches up with the yellow. Okay, now next up we can simplify. Do you see we'll have 2 minus 2 inside, which is 0. So we'll get 0 minus 7 x's. And then we'll have 2 minus 5 times negative 7x. And then we will have negative 5 times negative 7x is 2 plus 35 x's. And we're all done. How'd you guys do? Awesome! I bet that's getting a little easier for you now. Okay, next up, we're going to graph using slope and y-intercept. So what do we do when we're using this format? Good, we need to isolate the y. So here we go. We're just going to add x over 3. Don't worry about that fraction. Remember, fractions are your friend. So this will give us on this side, remember, we'll have 0 x's minus y over 4 equals, I'm going to write this as 1/3 times x. X over 3 is the same as 1/3 times x. So this expression here is equivalent to this guy here. Now 0 x's is of course 0. So we'll have negative y over 4 equals 1/3 times x plus 1. Now remember, we want a coefficient of 1 in front of the y. So in order for that to happen, we're going to need to multiply this guy by negative 4. And to balance that out, we need to multiply the other binomial by. So this will give us a result of y is equal to negative 4/3 times x, and then negative 4 times 1 is just minus 4. So m is the coefficient to the x, and so we get negative 4/3, and then we have, so it's up to you. Let's take a look. Our y-intercept is going to be the ordered pair 0, negative 4. So why don't we go ahead and have our slope be, we'll go 4 up, and then we'll go 3 left. All right, because remember it's rise over run. So, and this is where we got that information here. That was our slope. And we're going to use it like this. And then we got our, y-intercept from the -4 down there. So, all right. Now, I would recommend that we make our scale since we do, let's see. Let's just go ahead and do the regular scale since our intercept is at an integer. So this will be at, you know, the x will be -10 to 10, and the y's will also go from -10 to 10. And we'll make our graph. So our intercept was at 0, -4, so 1, 2, 3, 4. And then we'll be going up 4. So my second point I'm getting from going up 4, 1, 2, 3, 4, to the left 3, 1, 2, 3. So then my line will look something like that. You know what? Let's try that again. I don't like how that one turned out. Going something like that. Okay? Now on with the show. Point slope form. We can use the slope of a line to obtain another useful form of the line's equation. Consider a non-vertical line that has slope m and contains the point x1, y1. Now this is a point other than the y-intercept. Now let x and y, x comma y, represent any other point on the line. Now the x1, y1 ordered pair is a point that's fixed that you know. The other one, x comma y, it can vary, so that's not fixed at all. So the point xy is arbitrary and is not in one fixed position. The point x1, y1 is fixed. Okay, so here we go. Do you guys remember the general slope formula? So we'll have our, in this case, our x1, y1, okay, is still going to be the first order pair, but let's let x comma y be the second one. So do you see, if we went here and we said, okay, m is equal to the second point y coordinate, which we said was y, minus the first point y coordinate, y1, over the second point x coordinate, which we said was x, minus the first point x coordinate, which was x1. Now in this case, instead of isolating y, we're going to isolate y minus y1. Okay, so we want to isolate y minus y1. So in order to do that, if we were to multiply both sides by x minus x1, I know it looks odd, don't worry about it. What will happen is we'll get x minus x1 times m is equal to, do you see how these will completely divide out to be 1? So we'll have y minus y1. Now, if that statement is true, then doesn't this have to be true? Y minus y1 has to equal to x minus x1 times m. Good. Now if I commute the second two factors, then I will have y minus y1 is equal to m times x minus x1. And there you have it, folks. That's the slope-intercept. I apologize. That is the point-slope form of the line. All right, so here we go. The point-slope form of the equation of a non-vertical line with slope m that passes through the point x1, y1 is y minus y1 is equal to the slope times x minus x1. All right, so here we go. Let's work on the first example. We want to write the point-slope form of the equation of the line with the given slope that passes through the given point. So m is -2, and you see this guy is our x1, y1. So until you remember the formula by heart, just rewrite it. Y minus y1 equals the slope times x minus x1. Right? So remember that this guy was y1 right here, and then this guy here is my x1, and my slope is the -2. So plugging it all in, we get y minus -11 is equal to the slope times x minus 5. So this here was my y1, this was my slope, and this guy was my x1. Now we can clean that up a wee bit and write it as y plus 11 is -2 times x minus 5. And we're all done. Okay, go ahead and pause the movie and work on part B. Alrighty, let's see how you did. We've got our slope, which is the 5/8. We have our x1 is 1/4 and y1 is 7. So again, y minus y1 is the slope times x minus x1. And this was the slope. It goes here, x1 goes here, and y1 goes here. So plugging it all in, we have y minus 7 equals 5/8 times x minus 1/4. And you're all done. Isn't that beautiful? And again, what we have found here for both of these are the point-slope form. Okay, why don't we have you try C and D. Pause the movie and give C and D a try. Alrighty, let's see how you did. Again, we're just plugging everything in. Notice that, so here we have a slope of 0. x1 is -21 and y1 is 5. So y minus y1 equals the slope times x minus x1. Y minus 5 equals 0 times x minus -21. Now, isn't 0 times anything? Good. 0 times anything is 0. So when you have a 0 slope, what happens is you get y minus 5 is 0. And so what kind of line is this? Y equals 5. Good, that's a horizontal line, a horizontal line. So here, just a reminder that if there's a zero slope, there's no rise, which yields a horizontal line. Okay, let's see what happens here. And I bet you guys got it now. Undefined slope. Undefined slope. Remember, that means there's no run. So x is always the same number. So what is x? Good, x has to be 0, right? So this is a vertical line. We know that because of the undefined slope. Okay, and we knew this was a horizontal line because of the 0 slope. So on a vertical line, x is always the same number, and since it goes through the point 0, 0, x must be 0. Okay? Alrighty. Next example. Now we want to use the graph to find two equations of the line in point-slope form. Okay? So again, it's good to use points like this one and this one, that corner exactly. Right? So remember, this is the point 0, 5. This is the point 1, 2. So for the first one, we'll use y minus y1, which is 5, is equal to the slope. Now, what the heck is the slope? Remember, we're going 1, 2, 3 down and 1 to the right, aren't we? That's 3 down, 1 to the right. Okay? So that, of course, gives us a slope of -3. So here we'll get -3 times x minus 0. So these are going to be our x1s for the two different lines and y1s for the two different lines, and the slope for these lines. Now, of course, this would simplify to be y minus 5 equals -3x's, or you could just leave it like as is above. You know, since we're learning point-slope form, let's just do it as it is above, and we're good. Put our happy box around the answer. All right, here we are. Next up, y minus, what's our y1? Good, 2 equals, the slope was -3, awesome, times x minus 1. Good. So here's our x1, here's our y1, and here's our slope, and we're all done. All right, so now we want to take these and write them in slope-intercept form. So y minus 5 equals -3 times x minus 0 is the first one. And then that second one I'll just write down. Y minus 2 is -3 times x minus 1. So we're going to learn something really interesting here. So go ahead. How do we get this in slope-intercept form? Great. We are going to isolate the y. Isolate the y. So go ahead and do that. And pause the movie and do that for each of those equations, and then check out what you found. So what did you learn? They're the same. So when we have the slope-intercept form of the line, that's kind of a special form because the answer is unique. There is only one form of the slope-intercept form of the line, where there are infinitely many formats for the point-slope form of the line. So here we go. If we take our next step, we have y minus 5 equals -3x. If we add 5 to both sides, we get y equals negative 3x plus 5. That's our slope-intercept form for the first one. Now the second guy, I'll distribute the negative 3 throughout that quantity to get this, negative 3x plus 3. Adding 2 to both sides, we will get negative 3x plus 5. See, they are the same. So that means that we can make this conclusion, the slope-intercept form of the equation, the equation of a line is unique. Okay. Next up, equations of lines. Equations of lines. So, standard form of a line, remember, was ax plus by equals c. What you should know, you graph equations in this form using intercepts. That's often very easy. And a checkpoint. Y equals b. Graph equations in this form as what kind of lines? Cool, horizontal lines with b as the y-coordinate of the y-intercept. X equals a. Graph equations in this form as vertical lines. There you are. With a as the x-intercept. Slope-intercept form. That was good. Y equals m times x plus b. Graph equations in this form using the y-intercept b. Remember, we got our first point using that. And the slope, which is m. Start with this form when writing a linear equation if you know a line's slope and y-intercept. Part of your job will be writing equations of lines given certain information. So if you've been given the slope and y-intercept, that's how you would go about writing the equation of the line. Point-slope form of a line. So remember, that was y minus y1 is equal to the slope times x minus x1. Start with this form when writing a linear equation. If you know the slope of the line, and a point on the line not containing the y-intercept, because if you have the y-intercept, you use the easier format, the y equals mx plus b. Or what if you know 2 points on the line, and that's it, right? Neither of which contains the y-intercept. So what would we have to find? If you know 2 points, you can find the, we can calculate the slope using m equals y2 minus y1 over x2 minus x1. So that gets, a wee bit more complicated when you've got to do that stuff. Right? Okay, so here we go. Here's some examples. And, oh, wait, one more thing. Parallel and perpendicular lines. So recall that parallel lines have the what kind of slope? Good, the same slope. And perpendicular lines have slopes which are negative reciprocals. Right? Remember, if you multiply the two slopes together, you would get a result of -1. All right, example 3. Use the given conditions to write an equation for each line in point-slope form and slope-intercept form. Right? So here we are. What clues have we been given? It passes through a certain point, so that's going to be our x1, y1 right here. And parallel to the line whose equation is y equals -5 times x plus 4. So remember, again, we had something like this, I think, in the last section. We have another line, right, that we have to get information from in order to make the equation for our line, which is different than that one. So here we go. This part of it, right? So remember, we have to find what? Parallel lines have the same, good, the same slope. So we need to figure out what the slope is. Do you see m equals -5, because that's already in slope-intercept form? Right? So we're going to go ahead and use that slope for this one. So here we go. We have m is -5, which we found from that other line, and x1, y1 is -2, -7. So y minus y1, I got to start by the slope-intercept, is equal to m times x minus x1. So y minus, good, -7 is equal to the slope, -5 times x minus -2. So here's my x1. Didn't want that there. My x1. And my y1. And my slope, okay, which we found from the initial line. So point slope form is going to be, do you see, if I do minus and minus, I get plus. So I'll get y plus 7 equals -5 times x plus 2. That's my point slope form. Okay, now slope-intercept, what do I have to do? Good, isolate y. So here, let's box this because we have part of our answer here. Right? Now we're going to start working on slope-intercept. So y plus 7 equals -5 times x plus 2. Y plus 7 is -5x's minus 10. I'm distributing the -5 through that quantity. Then, subtracting 7 from both sides, I will get -5x minus 17. So, slope-intercept form was y equals -5x minus 17. Okay. All right, so why don't you try, I think I got 2 more examples. So pause the movie and give those examples a try, right? I know you can do it. All right, let's see how you did. Again, we have information about a secondary line that we have to use first in order to figure out how to make the equation of our line. So here, the slope for this one is, I'll call it M1 because they're not going to be the same this time. So M1 is equal to negative 1/3. That's our slope for this line. Okay. Now perpendicular lines have slopes that are negative reciprocals, right? So you can either, if you're okay with reciprocals, the reciprocal of this would be negative 3/1. The negative reciprocal would be positive 3/1. Or you can say, M1 times M2 has to be negative 1. Well, negative 1/3 times M2, which will be the slope for our line, is negative 1. So if you multiplied both sides by negative 3, then we would get M2 is equal to positive 3. So, y minus y1 equals the slope times x minus x1. The slope we're using is the one we found here. Okay. So this is going to be our slope for this line. And then, as usual, y1 will be from the given point and x1 will be from the given point. So we'll have y minus 2 is equal to 3 times x minus negative 4. This is how everything matches up. And so the point slope form when I simplify a bit, will be y minus 2 is equal to 3 times x plus 4. Okay, now on to the slope-intercept form. So here, let's take our initial y minus 2 is equal to 3 times quantity x plus 4. I need to distribute the 3 throughout, and I'll get 3x's plus 12. And then if I add 2 to both sides, I'll get 3x plus 14. So the slope-intercept form is y equals 3x plus 14. All right. Now, passing through 5, negative 9, and parallel to the line whose equation is x plus 7y is 12. So parallel lines have the same slope. So here we are. X plus 7y equals 12. I need to isolate the y. So we'll get 7y is negative x plus 12. And if I multiply both sides by 1/7, I get y equals negative 1/7 x minus 12/7. So the slope is negative 1/7. Okay, for this, okay. Isolating y, we will get 7y is equal to negative x plus 12. Multiplying through by positive 1/7 will give us a 1 in front of the y. So we'll get negative 1/7 times x plus 12/7. And what's important here is the slope of negative 1/7. So we'll go back here. Y minus y1 is equal to the slope times x minus x1. Well, we found the slope over here, right, that we're using. We've got our y1 and our x1. So we have all the pieces for our slope-intercept form. All right. And cleaning it up, we'll get y plus 9 is equal to negative 1/7 times x minus 5. And that is our point slope form is y plus 9 equals negative 1/7 times x minus 5. And working on slope-intercept form, we need to isolate the y. So to do so, we need to distribute the negative 1/7 through that quantity. We will have y plus 9 equals negative 1/7 times x, and then we'll get plus 5/7. So subtracting 9 from both sides, we'll get y equals negative 1/7 x plus 5/7 minus 9. But we need a common denominator here. So do you see that if we multiply by 7/7, multiply that 9 by 7/7, we will get y equals negative 1/7 x plus 5/7 minus 63/7. And we'll get y equals negative 1/7 x. 5 minus 63 is going to give us 58. So we'll have a negative 58/7. So the slope-intercept form is going to be y is equal to negative 1/7 x minus 58/7. And we are all done with 3-5. So go ahead and do the homework for 3-5 and have a fabulous day.